Right, I think there's some issue there. I was talking about this. So you get a range of values as far as stationary, the body to remain stationary with respect to the incline is concerned. Now, this is very important. Every stage you have to look for both the options. Okay? Now, you got this. So, I have tried to show you. Put mu 0, you will get V is equal to tan beta. And when you take with tan beta, the body, even when it was a smooth incline, it used to remain stationary, right? Now, right. So I have shown you how to. Now there is one more thing which you may probably come across. This is beta. If you have a fixed incline, and suppose I'm horizontally pushing this with a force, we will say pulling, okay? It's a pulling. I'm pulling it with this. I want to know the minimum force for the body to slide down. So minimum force means we will take FL, and this is N mg cos beta mg sin beta. Okay. Now this and this. This is F cos beta. This is F sin beta. You said minimum, therefore these are all, both these things balance out. So FL is equal to F cos beta plus mg sin beta. N is N plus F sin beta is equal to mg cos beta. Now substitute that. FL is mu n, N is mg cos beta minus F sin beta is equal to F cos beta plus mg sin beta. Now F you have to bring on to one side. I'll take everything on cos beta plus mu sin beta. This is taken onto this side and this is brought onto this side. So you get mg into mu cos beta minus sin beta. So your F is equal to mg into mu cos beta by cos beta plus mu sin beta. This is the pulling force to just slide down the body because friction is very high. You can again, as before, divide numerator and denominator with cos beta. So you get mu minus tan beta upon 1 plus mu tan beta. Likewise, we are going to get that. Okay? This is how you have that pulling force. I hope this is clear to you. Okay. Now, but I think quite a few limiting frictional forces we considered. There are many. I think as as the time progresses, I think we will try to do that one by one. Uh, Before that, uh, you see, presuming friction. That is a rough surface. Just looking at a small portion, this one, this is d theta and this is theta. Now let me say this is pulling it down. Okay? This is t, this is t plus dt, a small rope, there. Now, if you really see this carefully, it's not slipping. What do you mean by that? Actually, the tension is more on this side. You know that very well. Tension is more on this side. That's why it is rotating. And friction would oppose. Then what do? I take t plus dt here and t there. So, this tension difference, that is dt, is balanced by whatever small frictional force, limiting frictional force that you have. And what are you actually trying to do here? This is how I am plotting here. Okay. This angle is d theta by 2. So, if this is d theta by 2, this is d theta by 2. So, you get t cos d theta by 2, t sin d theta by 2. And similarly here also, t sin d theta. What is the total force? 2t sin d theta by 2 is with which it is pressing this. Okay? So that is your normal force. And when you take d theta to be very small, you can take sin d theta is nearly equal to d theta. Then what do you get? 2t into, you can try this with your tables also. This, and if you know the series, then you will automatically know for small angle sin d theta is d theta, cos d theta is 1. So you get t d theta is equal to n, right? Then, so n means here dn, but that's small. So df is equal to, it is about to slip. So mu dn, dt is equal to mu, dn is t d theta, or dt by t is mu d theta. Here, where are you going from? 0 to pi. And here, on this side, you have, say, t1, t2. So you have L and T or Ln, or you can rewrite that as T2 by T1 is by R2. Now, if I want you to look at this problem with what I discussed before. I took a light pulley, smooth pulley. We took T1 and T2 to be same. But once it is rough, T1 and T2 are different. Since exactly this is 180 degrees, fine. So for example, you take a branch here, you are holding a rope. Suppose you have done that 3 times. So 0 to 2 pi, 4 pi, 6 pi. The number of turns into 2 pi, that is theta. So actually T2 is T1 e raised to mu theta. Theta and generalize, for example, 0 to pi you took. Possible that this may be your T1, this may be T2. So you have to look at this angle. That may be pi by 6, pi by 4, pi by 2, anything. That is what you have to substitute. You see, whenever you want to pull somebody, you tie a rope and then try to pull it like this. Okay? Fine. But when it is really heavy, if you do that, there is a chance of slipping here. So what do? You tie the rope some 3-4 times to your hand and then try to pull. Why? You don't know that it has some tremendous friction. So this is a branch of a tree and then you are trying to rope like that. You could see how many times you are going to get T2 is equal to T1 e raised to mu theta. The number of things, that is 2n pi. It's going to be a very, very huge value, remember that. Very huge value. You get my point? So if you try it a number of times, it is easy for you to hold on to such a heavy stuff. You have put around say 100 kilos, then you need not have to use so much of force because the friction takes care of much of it so that it doesn't slip anywhere. Got it? Or wherever you come across heavy or friction, rather rough pulley, then both sides friction tension will be different, and these are the tensions that you are going to get there. Okay? Alright. Now what do we do is a general thing that you come across, kinetic friction. When do you use kinetic friction? You know very well. When do you use kinetic friction? When the body starts slipping. So in all these cases you have to use a kinetic friction. I need not put that here every time. But if I apply a force equal to Fl, then this is Fk, M, N, Mg, A, F. So you have mu Lmg minus mu Kmg, Fl minus Fk. Don't think that this is Fl. That is actually applied force. Equivalent to limiting friction I am applying, what will happen? So A is equal to if you persist with the minimum required force to just move the body, body starts accelerating. This is the acceleration. Okay? Whenever required, we try to distinguish mu L and mu K. Other places I don't put, I'll keep on putting mu. Only in specific cases you can see that kind of a difference. Okay? Now, in the case of this fixed you know, so mg sin beta mg sin beta minus mu n from here till here, what time it takes. Since A is a constant, I think you can do that, etc. Okay? All that time avoiding discussing because the kinematics are simple to apply here. You can very easily do that. Okay? Very easily do that. Okay. For example, I'll just give you, here is a smooth incline. Here is a rough incline. Now, what is A here? What is A here? Okay? What if the length is L? What time it takes to reach time of descent? Under root 2s by the acceleration, the time of descent is so they may give problems like this. This comes very quick, it takes time. Maybe the time of descent in this case is rough, this is smooth. They'll say if TR is equal to NTS, supposing it takes for a given problem, then you may ask what is mu. So simply equate. What is TR is all this? You square so that I can write sin beta minus mu cos beta n square because I have a squared on both sides. G sin beta 2n. Now you have sin beta is equal to n square sin beta. Now bring on to this side. So mu is equal to cos beta. Likewise. How to work out those problems? You can easily do that. Whichever he says n times n is greater than 1, they will give n here. Don't memorize this formula. This is not a formula I am deriving for you. Concept I am trying to give you as to how to work out, that's all. In a similar way, you can also have what is the final velocity that you get here? Under root 2 a s. What do you get here? Under root whichever way. So this is for smooth. Again, they may give any relation, then you can try and then try to find out. Get the point here? So many ways to do this. They can ask any problem based on these simple things. Okay? Now, this is the body. I am applying a force F here. Let me say F is equal to Kx. Rather, I would say, okay, so we'll say F is equal to Kt. When we think I am starting to increase the force from time t is equal to 0. At what time the body starts moving? A simple, same case as I discussed before, how they can ask in a different way, I am trying to tell you. I draw a video as before. This is frictional force. This is M and G. Kt. Let me presume F is T is equal to T1 F is equal to body just begins to move. In which case, what do I do? FL is K, T1 is, FL is, mu N is, mu Ng, T1 is equal to mu Ng by K. You get the point? Now, once if for T less than T1, what is frictional force? Static frictional force. Got the point? At T is equal to T1, F is equal to FL. At T greater than T1, F is equal to Fk. If I plot all this, they ask you in many cases, remember, this is time, this is frictional force. Initially, T1, this is Fl. Afterwards, greater than T1, it becomes Fk, and that is constant. Here what happens, nobody knows. So this is how you are going to get the graph with the time, frictional force varying with the time. Like, just like that I'm telling you how it can be handled, right? I will be doing this kind of problems many in my probably next lecture, but I'm just giving an indication how I'm going into the complications, okay? Right. Now, there is another dimension to this problem. Supposing I'm applying a force F, mu is equal to mu naught into x. Suppose, or I'll take mu naught plus kx. This is how x is increasing. Supposing I am applying a force that let the body slip in the beginning. So body begins to see. Therefore, what is the acceleration? F minus Fk. Minus Fk is mu n. F minus mu n is equal to ma. F minus mu. Mu means mu naught plus kx. N is equal to mg is equal to ma. Because this is n. As the body starts moving, frictional force starts increasing. So that's how it's going to happen. So there is a stage when A becomes 0. Why? The F is not varying, but frictional force is increasing. Initially F is more, so it is accelerating. At one stage these two become equal, and that one, when is A equal to 0? If I put A equal to 0, this whole thing is 0, then F by mg minus mu naught 1 by k, let that be your x naught. That is where your acceleration becomes 0. Okay? If A is 0 at that time, what is the velocity? Why? Till then it is accelerating. And suppose if you persist with that, then what will happen? That opposing force will increase, body still keeps moving. So the body has velocity. So till A is positive, velocity goes on increasing. When A is 0, V becomes maximum. Afterwards what will happen? Velocity goes on decreasing, and finally becomes 0. I may ask, at what time velocity becomes 0? At what time the velocity is maximum, etc.? Then this is nothing but your variable acceleration. Okay? Variable acceleration. How do you do that? A is equal to F by m. Right. I'll write this as A naught minus G mu naught minus kgx. So what is B? A minus G mu naught, C is equal to kg. Okay? Alright. If A is this, A how you can write? Two ways you can write. V dV by dx or dV by dt. Then what do you get here? Now you should understand that you cannot use your 9th class kinematic relations here. Okay? Now you can integrate this. V square by 2, 0 to. Now what is it that you want to see? Say for example, V max. Then this is Vx minus Cx square by 2, x is equal to 0 to x naught. Because Vmax is at x is equal to x naught. So what do you get? Is equal to 2 into Vx naught minus x naught square. V value you can substitute, C value you can substitute, x naught you can substitute, you will get the maximum velocity. That's how they may ask questions. Okay? Now this is as far as maximum velocity is concerned. Okay, so you got it. Fine. All right. Supposing I want to know when does this velocity become zero? Where does the body stop? So I'll take 0 to 0. 0 to 0. Then what will happen? This becomes, the whole thing becomes 0. So 0 to, I'll say x. So you have bx minus cx square by 2 is equal to 0. One is, of course, x is equal to 0, velocity is 0. The other is Rx is equal to 2b by c. 2b at this distance you have this this is the distance traveled before it comes to a stop. This is variable mu. Variable mu, therefore variable acceleration, variable retardation, you got all those things, and then you got this answer. I hope this is clear to you. Okay? Right. So you got it? The rest, next we will continue later.